AP problem 11 says consider the carbon dioxide molecule CO2 and the carbonate ion CO3 2-. Draw the complete Lewis electron dot structure for each species. Okay, so for part AI, this is the CO2 structure. It's got a carbon in the middle with double bonds with 2 O's on the side. And then for the CO3 2-, it has this carbon in the middle and then a double bond with 1 O and then 2 single bonds with the other 2 oxygens. And then it has a resonance structure where the double bond changes between the O's. Okay. And then II says account for the fact that carbon-oxygen bond length in CO3 2- is greater than carbon and oxygen bond length in CO2. So I said that the carbon-oxygen interactions in CO2 are double bonds. So they're closer because the more bonds, the more the atoms are pulled to each other. However, the carbon-oxygen interaction in CO3 2- is in a resonance form with 1 double bond. So it's almost like each of these bonds is like 1 and 1/3 kind of. And this is less of a smaller bond number than a double bond. So, and the weaker the bonds are, the farther the atoms are. Part B says consider the molecule CF4 and SF4. And it says draw the complete Lewis structure or Lewis electron dot structure for each molecule. Part BI says CF4 is part BI says CF4 here, C in the middle with 4 F's around it. And then SF4 is similar. It's got S in the middle with 4 F's around it, but it has this lone pair here, which makes it different. Okay. And then part B, II says, in terms of molecule geometry, account for the fact that CF4 molecule is polar, whereas this SF4 molecule is polar, or CF4 is nonpolar and SF4 is polar. Okay. So, the only difference is this lone pair in S, so that is definitely going to be a factor. So the geometry of CF4 is a tetrahedral, and it's symmetrical on every side, like every side is the same. And that makes it nonpolar, because the charge is all the same. However, in the SF4, the lone pair makes it trigonal bipyramidal, and because of that, it's not symmetrical. And then the electrons favor one of the sides, and that makes it charged on one of the sides, which makes it polar.